I said everything gonna be alright. I said everything's going to be all right. Good day wherever you're listening from, and welcome to Indoor Air Quality Radio, IAQ Radio. It's Friday, April 1st, 2016, April Fool's Day. This week is episode 408. My name is Radio Joe Hughes, and at the controls is our engineer, John. You got to have faith. Joining me from Studio C in McKees Rocks is the Z-Man, Cliff Zlotnick.
Hey, Joe. Hello, everybody.
Good day, Cliff. This week we're going to interview David Johnston. He's a builder, been in building energy efficient and, custom energy efficient homes in Maine for about 35 years now. We're going to try and get a little real world perspective on energy efficiency, indoor air quality, and building science. Before we get started, though, we couldn't do the show without our marquee sponsors.
John Don Products, where restoration and abatement contractors shop. Visit them at their website, jondon.com. That's jondon.com.
Clean Facts, the number one information source for cleaning and restoration professionals. Check them out at cleanfactswithanx.com.
IAQ.net and Healthy Indoors Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at IAQ.net.
And Particles Plus. They are engineers and manufacturers of feature-rich particle counters, air quality monitoring instrumentation, and vacuum pump technology. ParticlesPlus.com. Count on us.
Please be sure to thank our sponsors for their support of IAQ Radio when you inquire about their services and products.
Okay, and last but not least, please visit the IAQ Training Institute website for the most current dates for the training you trust at IAQtraining.com. All right, let's turn it over to the Z-Man for today's IAQ Radio Trivia question.
Thanks, Joe. Win a cool prize by outcompeting fellow IAQ Radio listeners and being the first person to correctly answer the IAQ Radio trivia question each week. Submitting your answer is easy. Either email it to cslotnick@cs.com, or if you're listening to the show live, you can text them the answer via your computer. Congratulations. To Brian Baker, Custom Vac, Winnipeg, Manitoba, Canada, for the first correct answer to last week's IAQ Radio Trivia question. The IAQ Radio Trivia question for Friday, April 1st, 2016, has been sponsored by Ideas LLC, the solution chemistry company, creating unique solutions to odor removal, surface cleaning, and decontamination problems. Now for this week's IAQ Radio Trivia question. What is the traditional unit of work equal to approximately 1,055 joules? Back to you, Joe.
All right. Thanks, Cliff. By the way, I've got some really nice prizes for the trivia question sent by Brian Baker up in Canada, so jump on that one if you can. Okay. Today's guest is David Johnston. David he's a builder out of, Gorham, Maine. And he's the president of Dave Johnston Company. He's been building custom, energy-efficient, healthy homes in Maine for over 35 years. He was a building energy-efficient homes with a focus on indoor air quality long before it was mainstream thing to do. In addition to being a builder, he teaches building construction trade classes at Central Maine Community College and has served as an adjunct instructor in the residential design and drafting and graphic designs at the University of Southern Maine. He's also currently on the advisory committees for the Southern Maine Community College, Central Maine Community College, and the Westbrook Region Technology Center. He has a BS degree in industrial arts education from the University of Southern Maine, and his associate's degree was in oceanography and marine biology. We've got some music for David.
Coal, oil, and natural gas, fossil fuels that will not last. What can all the people do Use less of these, use alternatives too. Animals and plants from years gone past gave us the fuels that we use too fast. We can't make more of these fuels. We need to conserve and not be fools.
All right, let's conserve and not be fools. David, do we have you on the line?
Good afternoon.
Great to have you.
Here.
It's great to have you. We got to chat a little yesterday. I enjoyed that. We have a similar background. Both started teaching, and then I went into the indoor air quality consulting world, and you were a builder, and you've been building for a long time. What made you decide to go full-time into being a custom builder?
Well, when we first were looking at properties to move into, my wife and I was pretty horrified by what I saw existing, so I had it in my head I'd really like to build my own. And I was fortunate to be able to do that. That got me started in the building trade, and I've stayed in it ever since, along with teaching. I taught as I built as well.
Okay. I didn't know you continued along that line. And you continue to teach now at some of the community colleges up in Maine?
That's right. Right. I figure it's time to pay back some of the things that I've learned over the years.
Yeah. Good.
So I enjoy it. I always did enjoy teaching. The money was not very great, as you remember, in those days.
That was the tough part.
Right.
I was a sub, and $50 a day was a little tough to feed a family on.
Yeah, that's what we talked about yesterday. That's right.
Yep. Now, how did you get interested in indoor air quality and energy efficiency? Was that something that you were interested in, right off the bat, or did that come along a little later?
No, that came right off the bat. I had lived for a couple of winters in an old farmhouse here in Southern Maine many years ago, and it was like trying to heat a lobster trap. The wind blew through it. And I swore then and there that when I had a chance to build, I would build something that would be comfortable for years to come, energy efficient. So it was always there. Then at the University of Southern Maine, a professor pointed me in that direction as well, and we started to collaborate with designs, and I've been doing it ever since. So it was always energy efficient. That then brought about the concerns for indoor air quality because we kept making the houses tighter and tighter, and trapping more and more indoor pollutants. So we quickly realized we had to ventilate, or at least eliminate the pollutants.
What happened? I mean, how did that, maybe you could expand on that a little bit more, because today, there's a big push for energy efficiency. We've got thousands and thousands of people out there evaluating homes, tightening up homes, adding insulation to their homes. What kind of results did you see when you were doing that early on without realizing what it might do to the indoor air quality?
Primarily, we were seeing moisture build up and using that as a guideline. Obviously, if moisture is building up, then other things must be as well. That was the telltale, to see it on the windows in the winter, for instance. So we realized again that we had to add leakage back to the house. That's the best way to put it. Cut some holes in it, but not just any hole. Try to get a balanced system. So very early on, we were using the old Mitsubishi Losnay air exchangers. They were just through the wall units that really didn't work very well, but at least it got us started thinking along those terms. And as they improved, as the technology improved, we followed that and put in better units. We talked yesterday, Van E was an early player in the air exchange or ventilation field. And we didn't want to just have exhaust-only systems. If we've gone to great lengths for energy efficiency, it didn't make sense to then blow all the heat outdoors.
I see.
So we wanted more of a balanced system.
And was that air exchange?
It was seat of the pants back then. It was. There wasn't a lot out there, not a lot of literature or product.
What year are we talking about here? What time frame?
1979 is the first version. My own house that I live in is 1982, but prior to that it was a lot of passive solar type houses. But still trying to get them as airtight as we could. They were never as tight as the newer or the double wall or the super insulated buildings that came later. But they were still tighter than the average house that was being built in the 70s, late 70s.
Were you doing any testing on them back then, blower door testing or anything like that?
Not on the passive solar, because that they weren't really tight enough to require that. When we got into the super insulated version, and that solved a lot of problems that were inherent in passive solar design. My own house being the first one that was blower door tested by the Princeton house doctors, Ken Gadsby and Gautam Dutt. Ken has since passed away. I believe Gautam is still alive. They came from Princeton University and did an infrared scan with old military equipment and a blower door test, and they said at the time it was the tightest house they had ever tested. Mine tested at that time. I suspect it's a little leakier now because it's 35 years old, but about 0.1 ACH 50.
And what were the changes you made when you went from the passive solar to the super insulated, the tighter homes? Where were the key, what were the key changes that you made in the construction technique?
I always viewed passive solar design like a three-legged milking stool. We needed incoming solar radiation to make them perform, so lots of south-facing glass. Then we needed to try and maintain that energy that was emitted through the glass via mass, either concrete floors or I never did get into the water walls, the trom walls, or those types of things, but mostly the mass of the house itself. And then some level of insulation to keep it in during the night when the sun wasn't shining. But with all the glass, it was just inherently losing heat. We tried window quilts and so forth, but expense. And we found people were complaining about needing sunglasses in their house and fading carpets and destroyed couches from ultraviolet radiation. So we decided to minimize, not eliminate, but downsize the amount of south-facing glass, increase the insulation values to do a better job holding it in, and decrease the mass because we found we didn't need it. That we started to call that pass-up houses, passive solar super insulated, combine the two houses you can't pass up. It didn't really go anywhere. We dropped that a long time ago. But we found that increasing the insulation and air tightness made the biggest difference, still with a sufficient amount of south-facing glass, if possible, that the house is heated very well when the sun was shining, mine being a very good example.
Now, what about the air, tightening up the air leakage? Where are the key areas in the home you found that needed more attention with respect to air?
Window installation and window construction. In the very early days of the passive solar, we were building our own windows according to some methods propounded by local building schools up here. Buying window sash or sliding glass door sash and building your own wooden frames, but they tended to leak pretty badly. So we had to keep working harder and harder on the windows. That seemed to be the biggest source, but also any joints between different surfaces, corners, wall to floor joints. Got into caulking those early on and found a tremendous increase in air tightness by doing that. We were amazed at how much leakage went between the sill plate and the plywood floor. Even with the exterior plywood somewhat blocking it off, it still leaked pretty badly. So again, seat of the pants, we kept just increasing the tightness to the point that we had some pretty successful versions. And then found that people were complaining a little bit about stuffiness. I said, let's take care of that right away, quick. And today's stuff is so good. It's a joy to put them in. Their efficiencies are so great, and the methods now are so simple. I'm amazed we don't put them in more houses in this country like they do in Canada. And by that I mean balanced recovery ventilation systems.
Cliff, I want to make sure you get a chance to jump in here. Anything you wanted to add there?
I'm good for the time being.
Okay. Well, I'm curious with respect to, you're a custom builder. You focus on energy savings and indoor air quality. I'm curious, how has that been received by customers over the years? I mean, when you first started doing this, did you get a lot of resistance? Is there less resistance now than there was then?
I actually never had to deal with resistance or even selling. People were coming to us already believing in what we were doing. So I I really didn't have resistance. The resistance might have been me trying to convince people to build it a little smaller and a little simpler. They're saying, we want a double-wall, super-insulated house. Well, one gentleman had a living room that was going to be 4,000 square feet. So I was resistant. It wasn't the customer. So when your customers already believe in what you're selling, it's relatively easy. As far as today, I think there's stated interest in energy efficiency and better methods of construction. And by that, I mean people say it. They give it lip service. But I don't think they really mean it in general. I think given the choice between a better insulation package and air sealing or granite countertops, the granite countertop will win with most buyers. I shouldn't say that, but I can't help myself.
Well,
the ones that I deal with, it's much less of an issue.
Less of an issue for you because they're coming to you because of that in the first place.
Because they're coming to me because they've done the research and they've found someone that does what they already believe in. So it's relatively straightforward.
How many homes a year do you build?
What's that?
How many homes a year do you build?
In my heyday, which is not now, maybe 6,
okay.
5 or 6. So over the years, it's amounted to a number of houses. And then always some additions or renovations to pay the bills, certainly when there's no new construction going on. Now it's probably 2 or 3 a year, and that will be getting advanced after 35, 40 years of doing this. But as we talked yesterday, retirement beckons. But I'll still teach to
partial
pass it back,
retirement.
Hopefully others will pick it up and run with it.
A little partial retirement. Well, I'm sure you'll still be out there teaching. Now,
right.
With respect to energy efficient homes, what's more important, air sealing or insulation?
I saw that question and it reminded me of a jokey question I'll ask students. What's better, volts or amps? And there's really no answer to that because both are required to generate current. And the same thing to this question. They're certainly very much equally important. For a long time, air sealing was not given the importance that it deserves today. I think people thought that if 6 inches of insulation is great, 12 inches would be twice as good, and then do nothing about leaky windows or connections and caulking and so forth. And I'd tell them, no, air sealing is the low-hanging fruit. Let's take care of that first and then play with the insulation values. Doubling it doesn't necessarily make it twice as good, but increasing your air tightness by a factor of 2 is direct payment. So it's obviously I'm attaching great significance to air sealing to prevent convective loss, but insulation will prevent conductive loss, and that's one of the important issues of building science. The 3 ways heat moves: convection, conduction, and radiation. And I'll talk more about radiation coming up, I'm sure, especially this coming weekend.
I'm sure you will, but let's talk a little bit about that now. You were building these, passive solar homes. You kind of got away from that to some degree. You're still incorporating south-facing windows to some degree, if I'm not mistaken. Is that accurate?
Every time I can, I do, and sometimes I just can't because of the neighborhood they're in, or they don't control pine trees that are on the south face. They don't own them. They can't cut them down. So sometimes it's just we can't do it. The super-insulated homes still work very well. You don't get the free heat from incoming solar radiation. But heat loss via radiation is a critical element. Our bodies radiate heat at a fairly uniform rate to anything that's colder around us. If I build walls that have through-the-wall studding, just standard cavity-only insulation, I've got some cold spots, and I will lose heat at a pretty consistent clip, about 9 watts per degree temperature difference between me and my wall nearby. So I'm telling designers and students to build walls that will be warm. So there's the insulation value. Air sealing won't create warm walls. But if I've increased the temperature significantly on the wall surface and glass surface, triple glazing being better than double glazing for that reason, my own metabolic rate will keep me warm. I won't be losing the heat that I'm generating in my body, which would radiate towards the glass and colder walls. So it's actually very critical and has never really been given its full value.
Plus,
of attention.
You're more comfortable as well, I would assume.
Way more comfortable. It's how radiant floor heat works. It doesn't really heat us. It just heats the surrounding walls and ceilings and floors. So I'm not radiating my own body heat away. Radiant floor heat is fabulous, done correctly.
You mentioned windows, and I know, at least I'm pretty sure windows have come a long way since the days when you first started building homes. Let's talk a little bit about that. And you also mentioned with insulation, there's the point of diminishing returns, and I'm wondering if the same is true with windows.
It's interesting. I like that expression, diminishing return, and I definitely use it with insulation, and I'm sure you do as well. And I'm beginning to wonder if windows aren't going the way of the old razor blades. The Track 2 had 2 blades. Well, then they came out with one with 4 blades. And you wonder, are they going to come out with 12 blades? And you'll shave even closer. I think the maximum glazing would be 3. And there are times when I can't justify that. So I like your thinking, diminishing return. I like triple glazing, but there are times when either cost-wise it just doesn't quite make sense, or it's not available in the window style customers want. Certainly double glazing, and with the new inert gas and the current generation of windows, they're very, very good. Triple is better. Is it 3 times as good as single? Probably not. Is it 30% or 50% better than double? Probably not.
Okay.
But it is, if the budget fits and the style fits, then triple glazing works fairly well. A lot of the European windows, Intus, Bieber, different window manufacturers with the tilt and turn types, I know you're familiar with it. They're excellent windows. They're very, very heavy because of the triple glazing. And they open in, which makes screening them very difficult. But triple glazing is marginally worth it, and if you're trying to reach passive standards, then it's virtually a requirement. I don't try to reach those standards. I'm comfortable with a very good but not overboard type concept and construction. I've never gone after the ratings for passive.
What about the cost factor? How big of a price difference is it between? I mean, I think everybody goes with at least a double pane window now, as maybe not triple. What's the price differential between your standard double and then going to a triple?
The probably about 25-30% more.
Okay.
For the triple glazing. Again, it's a little difficult to make that direct comparison. You're not likely to find, and I'm sure if someone's listening will say otherwise, but double hung type triple glazings that work really well. Just the weight of the situation. They tend to be swinging, and that may or may not work with everyone in their design style. But generally, I'd run about 25-30% more for the triple glazing.
Can you give us your thoughts on the low E windows and the variability there, and what you prefer in your climate?
Low E, definitely. That seems to help the re-radiation back through the glass. It keeps the infrared, the ultraviolet passing through, becoming infrared, going back out, it bounces it back in. So that was a good technology. Excuse me. And there are times when I'll use other coatings as well, solar control on a west-facing wall to control low-setting summer sun so it won't overheat the house. But low E is a standard, and the argon filled. Although there were some failures in some of the manufacturers, Anderson being one, they stood behind it very well for me. I have used Anderson many times in the past, where the gas was leaking out of the double pane, and the 2 panes were pushed together by atmospheric pressure. And you could see condensation in the center of the sash. Okay. Collapsed glass, but they keep working bugs out of things. We've seen it all over 35 years, haven't we?
Absolutely. It's been fascinating, actually, and
it really has been. Yeah.
But over that 35 years, you if I'm not mistaken, you got started with the double wall construction pretty early on. Is that accurate? And can you tell people what double wall is?
Very accurate. The first one we did was 1981, 82, and I've stayed with it ever since. I've done other methods, foam on the outside, foam on the inside, to break the stud path, because I've always been anxious to do that. But I keep coming back to the double wall. It's you've got the question here in front of me that you were asking. It's basically two 2x4 walls, in my case separated by about a 3-inch space. The entire wall is insulated. There's no air space in between, not an envelope home. That 10-inch thickness seems to work really well. It enables me to put the membrane, and we use a high strength cross-laminated polyethylene membrane behind the inner wall. So the outer 2/3 of the wall gets blown in, the inner third, the inner stud gets batted, but all the wiring and outlets are inside the membrane. And the membrane is in an exact right position now, because more and more people are asking me to air condition their houses in the summer. You know as well as I do that the vapor barrier should be on the warm side, but the question is, where is the warm side as seasons change? If it's internal in the wall, it's worked perfectly for 35 years. I've never had any issues with it. And it acts as an air barrier. It just makes the house very, very tight, that intact membrane all the way around.
And the studs between the inner wall and the outer wall are staggered to avoid any thermal bridges.
Yeah, actually, I've gone away from that and lined them up. There's still 3 inches separating, so there's no through-the-wall stud no matter what.
Okay.
But it actually works better for dense packing if the studs more or less line up. They can pack each bay, each deep bay better. I can get better results if I actually line the studs up. That was a discovery we made about 5 years ago, and it works every bit as well, if not better, than the staggered. Originally, they were staggered, yes.
Okay. And I'm curious with respect to, you said you tried having the insulation on the exterior. Did you run into problems with that, or was it just
Yes, I'm not a fan of foam on the outside of foundation walls or outside of walls, framed walls. I know others in the industry are, because it gives, keeps the studs warm, which is not a bad thing. But there's just the practicality of how do I attach siding on in my climate anyway, up here in Maine, zones 5 and 6 and 7, I have to have at least 2 inches of foam on the outside, and I prefer 4. I don't know how I can support 4 inches of, passing through 4 inches of foam with screws, 4 inches of unsupported screw shank, and then hang siding on the sheathing out beyond that. So it gets very tricky. I know some deal with it. I've just never felt comfortable. Plus, I've seen ants burrow into foam on the outside enough times that it makes me nervous. Not every time, but
it does happen.
You see it once, you know what happens.
Okay. What about on the exterior of foundation walls? What's your concern there?
Ants, in this case.
Okay.
I've done it. So my preference now is to do it on the inside. That's not to say I wouldn't do it on the outside, and obviously the insulated concrete form version, it definitely is on the outside as well as the inside. I think if it's treated rapidly and backfilled appropriately, there might not be an issue, but I have seen it.
Okay.
And it just makes me nervous. I try to think that the places I've built over the years will be around for 100 years with proper maintenance, and I don't think foam will be. We don't know what it's going to ultimately be. I've done models of various foam walls and kept them in the dark in my garage, and they still degrade, becoming a brownish powder.
Interesting.
There are others out there that use it and have had no issues, but I think I prefer dense pack cellulose and fiberglass or Roxel. I use a lot of that now.
You
the
do?
Mineral wool.
I see. And
it's just,
go ahead.
Just the double wall is more carpentry, but only carpentry. There's nothing, nothing's new involved in it, just some different methods, but not new product, not foam, closed cell, open cell, or things that haven't been proven yet.
So you're not using any foam, closed cell, open cell foam in your walls either?
Very, very little. Possibly at the sill plate, rim joist in the basement, foam that. But even then, I'd prefer cutting rigid foam, although that's still foam, but rigid foam, and then foaming it in around if the cuts aren't dead tight. But that would be about the limit of the foam that I'd use. I try to minimize it. It's very costly too. The double wall version, everyone would think it would be twice as much, but I tell people, what's the fastest part of construction? Erecting the walls. Leave for the day, come back, and all walls are built. Well, we're just doing it twice.
True.
So it's still fast. And insulation, fiberglass or dense packed cellulose is very affordable insulation. So we found that it adds about 3 to 5% to the average, to the cost of a double wall super insulated home with ventilation over one that isn't. Single wall and no ventilation.
3 to 5. That's not bad. That's pretty.
That's not bad at all. And with today's mortgage rates, I mean, when I built it, they were 18%. Today they're 3.5 or 4.
Amazing.
I mean, to borrow that extra 5%, it will pay for itself virtually from day one. The borrowed capital is only going to add about $1,200 a year, and you're going to save about $1,600 a year in fuel costs. So you're $400 to the good from day one.
Interesting. David, we've got to break and thank our sponsors. We're going to go to our halftime. A fascinating interview so far with David Johnston. We'll return for the second half of our interview in about 90 seconds, folks, so stick with us. And thanks to our association sponsors, the Indoor Air Quality Association, a nonprofit multidisciplinary organization dedicated to promoting the exchange of indoor environmental information through education and research. Visit them at IAQA.org.
The Restoration and Specialty Cleaners Association, who have been serving the needs of and advocating for their members for over 30 years. Remember, Triska is your link to industry training, certification, standards, and events. Their website is trsca.org. Thanks to our advertisers.
Gray Wolf Sensing Solutions, who use advanced sensor technology and embedded computers to provide superior environmental test instrumentation. Visit them at wolfsense.com.
Legends Environmental Insurance Services, the experts in insurance for environmental consultants and contractors for over 20 years. Visit them at legends-enviro.com, and, of course, our marquee sponsors. John Don Products, where restoration and abatement contractors shop. Visit them at their website, jondon.com. That's jondon.com.
CleanFacts, the #1 information source for cleaning and restoration professionals. Check them out at cleanfactswithanx.com.
IAQ.net and Healthy Indoors Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at IAQ.net.
And Particles Plus. They are engineers and manufacturers of feature-rich particle counters, air quality monitoring instrumentation, and vacuum pump technology. ParticlesPlus.com. Count on us.
Please be sure to thank our sponsors for their support of IAQ Radio when you inquire about their services and products.
Okay, we're back for the second half of our interview. We're talking to David Johnston of David Johnston and Company up in Maine. Been a builder of energy-efficient homes for 35 years now. David, well, Cliff, let me go to you first. Is there anything you wanted to get in here before we start with the second half?
No, you can go ahead, Joe.
Okay, I'm curious. We talked a little bit about insulation on foundations, and I wanted to talk a little bit about insulation on slabs. Can you describe for listeners how you handle insulation of slabs and foundations, and what that adds to the building, with respect to building science, why you're doing it the way you're doing it?
Here in the climate zone we live in Maine, specifically Zone 6, and we talked about this yesterday, we have frost penetration down about 4 feet. So if I'm building slabs, and I'm actually doing more and more of them because I like the concept of no stairs as I get older, we're doing a 4-foot frost wall and then filling in that box with compacted granular fill and insulating on top of that. I'll insulate the inside surface of the vertical wall, then apply 4 inches of extruded polystyrene on top of the compacted fill, add a vapor barrier membrane, wire mesh, and then in-floor heat tubing. I wouldn't pour a slab without putting in the tubing. So we've got a significant R value. However, there's always been an issue. The edge of slab would bleed heat. So I'm actually, pictures would be worth 1,000 words, but we haunch the top of the wall with a 5-inch lip or shelf that enables me to put another vertical piece of 1-inch foam, at least to create a thermal break so I'm not losing conductive loss out of the edge of the slab, then build on top of that. Again, back to the radiant portion, it maintains a very even slab temperature, which is a very massive piece of concrete. If that were significantly cooler than my body, I'm never going to be comfortable in that house. So at least 4 inches of foam under the slab is standard for me. I'll go up to 6, but after that it gets to the law of diminishing return. I've seen 12 inches, and it makes me shake my head.
And there's a
so I'm insulating internally and obviously under the slab.
Okay.
But the entire field, not 2 feet in or the entire thing. It certainly adds costs. Foam sheet goods are for 2 inches probably close to $45 a sheet. Once again, the smaller house, the better it is for people. That's been the toughest sell, though, to keep them small and simple.
Why do you think that is?
I don't know. People want sizzle with the steak, I guess. They need dormers. They need rounded surfaces or angles or, interest. No one wants to go back to the post-World War II small capes or ranches that were built on Long Island, for instance. And I get it. Aesthetics count. But the more complicated we make a house with the more surfaces, roof surfaces and wall surfaces, the more likelihood of leakage and just inherently the less energy efficient they can be. So there comes a diminishing return there too, I suppose, when they get too complicated. It doesn't really, I just shake my head and say, I don't know, what are you concerned about energy efficiency for? This is going to cost a fortune to build, let alone, I'll heat my house for years on the money you'll spend to build yours.
Interesting.
But so simpler is better, and insulating under the slab is a critical element because of that mass of concrete. Uninsulated concrete floors are just cold, even if they're not. They're so massive they're going to suck heat out of your bare feet, let's say, conductively, and definitely absorb it radiantly from your body.
Even with the radiant heat in there, you're having that issue.
With the radiant heat. I mean, I'm not going to put radiant heat in and not insulate under it because I don't want to have conductive loss to Mother Earth, which is a huge heat sink. So I've got to break it no matter what. Adding the in-floor tubing for in-floor heat, all I have to do is bring the slab temperature up to 85. The water temperature from the boiler can be very, very low, increasing efficiencies like crazy. I'm not getting heated by the floor. It's allowing me to maintain my own heat. And what a world of difference that makes. You're comfortable and you don't know why.
Interesting. We were talking a little bit about, I got one more question on the building enclosure, and that is attics. How are you insulating attics? Are you doing any of the insulation up above the roof deck, or are you keeping it all on the ceiling?
Only in renovations have I done it above the roof deck. And that has worked quite well. But in new construction, it would be internal. Either I'm insulating the roof slope, or there is no attic. And typically we use trusses up here, or I do, for super insulation, and it'll just be 2 feet or 30 inches of blown cellulose.
Okay.
But if the customer desires an attic, then I will incorporate the attic in the heated envelope and insulate the slopes of the roof, either with, in this case, possibly closed cell foam, or preferably air chutes and dense pack cellulose. And I've done it where I can hang. I've done it many times where I hang 2x4s using plywood gussets on to add to the depth of the rafters if it's not a trussed roof. Mm-hmm. So I can get 20 inches of dense pack cellulose in the slopes, and that's worked very well.
You seem to be.
But that's a rarity. Usually it's flat bottom or scissor type cathedral roof trusses that are much easier to insulate in general.
I see. Well, you seem to be a fan of the dense pack cellulose. Can you tell us why, as opposed to going with fiberglass or some other?
Fiberglass is inherently fiberglass bats is not dense enough to prevent airflow, so convective loss is almost a certainty through outlets, for instance, or around the windows. We've all pulled out insulation that's pretty black from dust. It's just filtering the dust out of the air that's blowing right through it. So I tend to stay away from just fiberglass. Matter of fact, I haven't used fiberglass in years. The dense pack is that much denser that it doesn't allow air to flow through it very easily at all. It's very affordable. It's recycled. I'm not so sure it prevents insects infestation of mice. I have seen those burrow through it, but it doesn't support ants.
Okay.
We do the best we can. But it would be a cost thing and an airflow thing. Closed cell foam would do those things as well, but it's got embedded energy. The cost of manufacturing it is not accounted for in my savings, but it's very expensive to make and somewhat harmful to the environment, or harmful to the environment as it's being made. So I'm not so sure it's the best product. But again, I have used it, and it does work. I'm not trying to imply that it doesn't.
And it sounds to me like you have used it. Maybe I'm mistaken. When you have to do a renovation and
yes.
You're going to fix an attic and you're going to move the insulation up to below the roof deck, are you using foam in that case more often than not?
I would use foam in that case and be happy with it. I mean, yes. Okay. There are times when it's required or needed and it makes good sense, and I'll use it. I did a renovation in the local town nearby here where there was just no possibility of increasing the thickness of the wall. They were at best 2x4, more like 2x3, and closed cell foam was the only way to come up with a package. And in addition to which, it stiffened the house tremendously. It was a really old, beat-up house, and doing this turned it into a much more rugged, although I wouldn't account for it structurally, but it certainly stiffened the house immensely.
That's a good point.
I couldn't get the roofers to go up on the roof until it was foamed. They went up and said, "We're not going up here." You could feel the house shudder in the wind.
Wow.
And once it was foamed, it stopped completely.
That's a very good point. Interesting. I was looking at a place that my son wants to buy, and it's got the same issue, and that might be a good reason to use the closed cell. You just have to be thoughtful about future wiring expansions. Electricians hate the closed cell foam for fishing purposes. But if you know something might be going upstairs, put a conduit in the wall, and you can take care of it that way. But the electricians really don't like it. And I can see why. We talked briefly yesterday when we chatted before the show about, you mentioned electricians hate it. I find our water damage restoration people have similar feelings about.
Really? Mm-hmm.
Yeah, because, when you get a leak, it can be very difficult to figure out where the leak is and how far it's spread, and trying to remove that stuff can be very difficult. So we were talking a little bit about
very valid point.
Yeah, that's something that, and Cliff, I know that's something that you have talked about in the past. I know. Is there anything you'd like to add?
No, not really.
Okay, I'm just curious. We talked briefly about restoration after water damage events, and you get a little bit of flooding, but you don't get many tornadoes or hurricanes or anything like that.
No, we get plenty of blizzards, but not tornadoes.
So I guess one of your issues is making sure that your structure is strong enough when you got 4 feet of snow on top of it too.
Yes, we have to account for at least 90 pounds per square foot snow load, and I would imagine you folks must be pretty close down there.
Yeah, where I'm at.
Yeah.
No.
Not this winter, which has been very mild, but the previous winter there was a number of collapses of older buildings that weren't capable of taking that weight. So once you see it happen, you say, I better take that seriously and construct this thing. We didn't really talk about structure, but it's obviously a key element in any kind of efficient construction. We want it to last, and that's a huge function of efficiency. To replace it after every 50 years is very inefficient. So we want to build things that will stand up.
Last 100 years. Is that your goal, 100-year home? Or?
Well, I like to think that. I'm probably patting myself on the back. Obviously, it would need maintenance, but it would be nice to think that it will. The older houses lasted as long as they did because they weren't heated or wired or plumbed they were pretty much like old barns, basically. But we're not going to go back to that type of living. We're going to always want comfort. So we're insulating and wiring, and so it's going to be difficult for houses to last 100, but it's my goal.
Let me move over a little more to the indoor air quality portion of a builder's perspective on indoor air quality. You started with concerns early on, and I think you told me you started working with Bill Turner early on, and I thought it was because of radon. Is that accurate?
Yes, that absolutely correct. Bill was involved in that through his work with Harvard School of Public Health, and then got involved in that with Terry Brennan, who I think you probably know. And then they contacted me to help them out, to go with them and learn more. I shouldn't say help them out, so I could be a helper. And we realized that the houses we were building, once we realized radon existed and it was an issue, we started testing, and sure enough found that we had to change our methods for the foundation and so forth, so that radon wouldn't get trapped in these much tighter houses. The tighter house can also prevent radon from coming in, but once it gets in, it's harder for it to get out. So our goal now, as you know, is to prevent it from coming in via subslab depressurization, which works quite well. And I think just pretty much uniform now, we have to adopt a radon-resistant new construction techniques, stone floors and piping in place. So if there's a radon issue, the remediation is easy and simple, inexpensive.
And then you started after that, I think we talked about having ventilation, and you talked a little bit about how in the early days ventilation was more difficult. Can you talk a little bit about why it's become so much?
There was very little dedicated equipment for it other than the units themselves, the recovery ventilators. Ductwork was just old-fashioned ductwork and difficult to run in solid-framed houses perpendicular to the joist directions. You'd have to build soffits, and it gets difficult just from a practical point of view. Today, in the last many years, there's flexible plastic ductwork that fits in stud walls, and it's just made it so much easier to install a system that, to me, there's no excuse not to, and you could even retrofit. I know Kurt Johnson was on your show, and he does that, and he does a great job retrofitting systems. But back in the early days, it was almost impossible. Today, there's other systems, too, of balanced ventilation. There's the recovery ventilators. There's also through-the-wall ceramic core blowers that do over-time balanced ventilation. Are you familiar with that?
Yes.
Yeah, I mean, that's a pretty good concept for renovation. I wouldn't do it in new construction because I don't have to, but just ventilation systems have improved and come down in price and complexity again, there's no excuse not to do it. And I'm referring again to balanced ventilation, recovery ventilation. I tend towards energy recovery, where I'm reintroducing moisture back into the house from the airstream. The earlier days we used heat recovery ventilators, which would actually were drying our houses out a little too much. People were complaining it was getting down below 30%, and they were seeing nosebleeds and raspy throats and furniture loosening. I like to see it around 30 to 40%, say 35 is a good average, and the energy recovery ventilators are maintaining that pretty nicely, if they have the appropriate core. And one make in particular has it that I've been very fortunate to have run across.
And who is that?
I mentioned it yesterday.
We can talk about it. Who is it?
Renew Air.
Renew
out
Air.
of Madison, Wisconsin.
You like their
I believe
product?
they were bought out by Solar in Palau, a multinational ventilation company, but their product is still the same and still tagged Renew Air, or
Now, could you
branded Renew Air, rather.
maybe describe for listeners, you've got this customer, excuse me, they want your home because they know, of your reputation, and they're willing to let you go ahead and design for you. Describe the ventilation system that you would like to see them put in.
I've a balanced system, and if I have my way, a Renew Air energy recovery ventilator located in the warm, in the conditioned space, not up in the attic where you can't get at it. And we will supply fresh air to the living areas, the living room, bedroom areas, and exhaust stale air from the odor-producing areas, the bath area and the kitchen area. I tend to still install a bath fan to get rid of the shower moisture more rapidly that's not interfaced with the ventilation system. Some builders interface it, and it works for them. I'm a little more cautious. I want to get rid of that moisture. They're very quiet. They're unobtrusive. The air streams have to be located, especially the supply side, where it's coming out of the ductwork, such that it's not over your head in your favorite reading chair.
Okay.
They won't use it. They'll shut it off because they'll feel that convective heat loss from their body. The flowing air around them will cool them down, and they won't use it. They have to be very quiet, or they won't use them. And these newer products are very quiet and low power consumption. They're a couple of 40-watt bulbs or less, basically. They don't add much cost to the operating cost of the house. The electrical bill stays pretty low. It's still a net loss of heat. I mean, even at their best efficiencies, 70, 80%, I'm still losing 20 or 30% of the heat that I paid for. But we have to ventilate. We can't let the pollutants, the indoor products, build up to unhealthy levels. And with that in mind, I'm trying to eliminate as much as possible. This is fairly new, combustion-type heating devices, or at least sealed combustion gas units are popular up here. And here we tend to use boilers rather than furnaces. We'll circulate liquid rather than air. But to a large extent, I'm trying to convince people to try the new ductless mini-split heating / air conditioning units. So
and how's that going?
We're introducing them. It's been working great. I have them in my house. We installed one 2 years ago, and it's heating the house in the dead of winter, just one unit. Again, it's a super insulated double wall, nicely built house. But it's costing me maybe $1.50 a day in the middle of winter to heat it with a mini split.
Wow! And
That's pretty cheap.
How many ton is it?
1.5, I think.
1.5. Okay. And just so listeners better understand, I think the system you were describing for ventilation, that would be a completely separate system. It's not tied into mechanical. You're more often than not using a boiler and pumping hot water or cold water.
Right.
Okay.
I know in other parts of the country where forced hot air is more popular, you can utilize the existing ductwork and use the distribution system there for bringing in fresh air into various parts of the house. Up here, it's so rare residentially. It's common commercially, but residentially it's rare that it's a standalone system.
So have you done some analysis on what the cost of that additional, you could go without it altogether, I guess, but what's the cost on that?
You mean the installed cost, not
Yes.
the operating cost?
The installed cost.
The installed cost, depending on the complexity of the house and size of the house, is going to run somewhere between $2,000 to $2,700 thereabouts. Okay. That's part of that 3 to 5% additional cost that I mentioned earlier.
Okay. Because you can't do one without the other.
Go ahead.
You can't do one without the other. You're not going to keep it tight and well insulated without adding the ventilation.
Right. I mean, I've been convinced by some whose budgets were so tight that exhaust only would suffice for them. I've never been happy about it, but it works. Exhaust only ventilation at least is getting rid of the pollutants. Where the makeup air is coming from, we don't really know. I try to tell them, well, crack a window so you know where it's coming from instead of from your basement. Mm-hmm. But I don't know how well that works. But yeah, generally it's viewed as this is a requirement. This is part of the house. It's not an option. But because of the nature of the insulation and airtightness and efficiency of the house, we can put in a much, much smaller heating system, which pretty much offsets it. Instead of the old 200,000 BTU boilers, they can be 60,000 BTU or less. And now with the mini split, they're so inexpensive that there's no reason, again, not to put in a ventilation system. I've had some customers say, well, the mini split is a ventilator, and no, it's not. It's purely a recirculator. It's not bringing in fresh air or exhausting stale air, but they look like it and they sound like it.
And they remove humidity too if you have the right one, and that probably confuses people too.
Right. I've run into a few snags with that in very efficient, smaller rooms or houses where we put those in. They heat beautifully, but come air conditioning season, they tend to short cycle. It cools the room down so rapidly that they just shut off, so they're no longer doing anything, and they were getting a little bit of moisture issue.
Interesting.
So we almost have to make them less efficient, the rooms, I mean, for air conditioning. If it's large enough, it's fine. But like my own office that I'm sitting in now, it's not very big and it's very well insulated. And the mini split heats it for about 50 cents a day, but cooling I'll see what happens this summer.
Interesting.
This could be a candidate for a paper.
I think that's an important point. Yeah, and it is. It's a very good candidate for a paper because they're becoming much more popular. And
they very much are, to the point that they're getting concerned that you're no longer getting the ventilation that you might have gotten from combustion devices. Like Bill Turner points out, the old atmospheric boilers, when they were running, were ventilators. The barometric damper in the basement was sucking air out of the house. So it was an exhaust system that we've never really considered, but now they're gone, and we've lost that 50 CFM or 30 CFM of ventilation.
Interesting. Cliff, before I go to my final couple of questions here, do you have anything you wanted to add or any questions?
No, I'm good, Joe.
Okay, great. Let me. I'd like to go over to your teaching activities for just a minute, David. You're teaching quite a bit. I don't know how much, but you are doing some building science related teaching, and then you're doing some other teaching. What's been your experience with the people coming into your program? Is it becoming more popular, less popular? How do you see that?
I'm very sad to say it's becoming less popular, and we're scratching our heads about it. The school that I teach at is doing fine, although we'd like to see the enrollment grow. But others in the state have shut down their construction technology programs entirely just recently. And it makes us wonder, where are the next generation of knowledgeable builders going to come from? Anyone up here, you and I talked about this yesterday, licensing is not required to be a general contractor in the state of Maine. I wish it was, and so do most builders, but it just doesn't seem to happen. So anyone can go out and hang up a magnetic sign on their pickup truck and they're a contractor, and we're seeing too much of that. We need to be licensed and professionalized so that continuing education is required. Then we'd see the enrollment grow. But, young people are saying, I can go out and start doing this without any education or any expense or any cost. I'm going to go do that. I think that's what's happening.
Well, that's as good a guess as any.
Nervous.
I've heard the same thing from others. I'm sorry to hear you're seeing the same thing because where are these guys?
Thing, yeah.
We're going to need
years ago. The local community college, Southern Maine, I would go there and hire carpenters every year, and they were wonderful. They were very knowledgeable and they had a good ethic. And the program had enrollments of 50 and 60 and double sections or triple sections. They just shut it down.
Wow. That's a shame.
I know.
That's really a shame.
Big
I don't know where these guys are going to come from, and that is going to be difficult. That's a big, difficult void to fill. I'm hearing the same thing with people going into the HVAC world. They are having problems. So this is an issue that we're going to have to pay more attention to. Why do you think?
I hear some people. Excuse me, just for a second. I hear some people complain that young people don't want to work, and I don't think that's true. I think they do. I think they're getting bad guidance that everyone has to go to college and become a computer operator. My subcontractors are all getting old. I mean, in their 50s and 60s, electricians and plumbers, and there's not very many new ones. I don't know what's going to happen 10 years from now when someone needs a plumber in a hurry.
Interesting thought. And I agree with you.
These people are more than willing to work. I think they need better guidance.
I agree. They are workers. I coach some junior high kids in basketball, and they come and work for the summer, and they have no problem with work. It's just they're not getting the guidance, like you say. And if these programs continue to shut down, where will they go? That's going to be tough. And
to resurrect a program that is shut down is a huge difficulty. It's so difficult to bring one back once it's down. The real estate, I mean, the rooms, the buildings that the programs were taking place in have been commandeered by other programs, so now they don't even have a space. Everything gets difficult. We'll see where we go.
I got one final question for you. We have a pretty good-sized group of people that listen to the show that they do indoor air quality investigations or mold inspections or, or both. From a builder's perspective, a guy that's been in here, he's built these buildings, you know what goes wrong with them. What should they be looking for? What are some of the key points or tips you can give them to keep an eye out for?
That's not that easily answered, I guess, because each house is so individual. But in a generic sense, I mean, the Maine Indoor Air Quality Council says keep buildings clean, warm, and dry. And clean is huge. If your listeners or these people that go into these places, go into a house and the basement is just chock full of stuff, it's bound to have issues. And I think they're nodding their heads. If they go into a place where the basement is relatively clean and visible, any problem that's there is going to be readily solved. These guys are very clever, I know, but if they can't see it or the clutter itself is the cause, that's difficult to fix. Years ago, when I did radon mitigation, you'd go into a house and you'd map it all out. Say, okay, we'll do this testing, and it should be simple. Then you'd get there and look, and you say, oh my God, I got to spend a day and a half emptying the basement so I can see what I'm doing. So clean is a big issue.
Huge point.
And warm and dry, just if it's dry, there's not going to be any mold. Or leakage. I hate to see clothes washers, up on the second floor of a two-story house where there's bedrooms. I did it for years. People convinced me that that's where the laundry is created, so why not have the machine there? But when the hose fails, not if, but when the hose fails, the water is cascading down through the entire house. So as much as I can now, I'm going back to my mother's days, saying the laundry really should be in the basement. If I'm going to have a massive plumbing leak, at least it's contained in the lowest level where it's going to go anyway.
Two great
not
points.
An easy sell. So I refuse now to put it on second story. I lose the argument on the first floor. It's going to go there, occasionally in the basement, but basement is the best. So if I were inspecting and saw an upstairs or even a first floor laundry, and I'd at least say, ma'am or sir, I shouldn't be sexist, do you shut off the machine between use, or are you relying only on the machine's solenoid valve to shut? The hose is charged and under pressure.
Good point. And has there been a previous
people
leak?
Shut it off. And the newer European machines, the shut-off is actually inaccessible behind the machine, so they never get shut off. And that hose is charged, and they fail. I know your disaster people will agree with me there. They've seen that way too many times.
Absolutely. And that's a good question to ask. Has it ever failed? Because sometimes people, they fail and they don't clean it up properly or dry it out properly. Right. And then,
Or I had a neighbor here in Gorham that they were away for the summer at their summer place, and it failed. They didn't come back for 3 months, and it was contained. It was draining down, but they had to gut the entire house because of someone forgot to shut off the washing machine.
Great points, David. Cliff, any final thoughts before we go?
Oh, good, Joe. Thanks.
David, before we go, we always like to give you the last word. This has been great. I've had a couple good comments already. People love to hear from the guy in the field actually doing this stuff. Any final thoughts for listeners?
I guess I'd be remiss if I don't put a plug in. You're coming for the Northeast Indoor Air Quality and Energy Conference in Portland, the 11th and 12th.
Absolutely.
Of this coming, this month. Come one, come all if you're up in the New England area. It's a great conference, and there's a lot of really good information. Certainly not just me. I'm kind of a hanger-on, but there's great things that'll be happening there.
Yeah,
so
we've got a lot of great
people, and I'm looking forward to seeing you.
Great speakers. You got Sam Rashkin. He's been on the show. Yeah. Ed Light will be there. He's been on the show. We've got a great lineup of speakers. I'm glad you brought that up because I was remiss in not mentioning it. We did put it out with the show announcement, made sure that people know. And please, if you do come by April 11th and 12th to the Northeast IEQ and Energy Conference in Portland, Maine, stop and say hello. We're going to be doing some live interviews from there, and then we're going to replay them later. And we're actually going to have some video on this one, too. Bob Krell from Healthy Indoors is coming, so it should be a great time. Well, David, thank you so much for joining us. It's been a great show. I've got some great comments already. Listening to common sense issues. Plumbing on upper floors are okay if people have mobility issues, but serve the rooms with drains. There you go. Have a good drain and flood-proof.
Yeah.
So
yeah.
Fantastic.
Which we've tried in the past, but when the hose blows, the drain isn't going to catch it.
It's not enough, huh?
Well, it's spraying all over the place.
True. Okay. Interesting.
Yeah.
Well, thanks again for joining us, David. It's been fascinating, and I look forward to meeting you in person in a week or so.
You betcha. I'm looking forward myself. Thank you so much.
My pleasure. This is Radio Joe Hughes saying thanks to this week's guest, David Johnston, out of Maine, a builder up in Maine. It was a fun show. I enjoy those kind of shows, and I get to ask questions that help my business as well. Hopefully it helped some of you out there learning a little bit more about the things that builders have to deal with. Next week I will be at some meetings in Atlanta. I've got to go to board meetings, and Cliff, I think, is going to be running on his own. Cliff, do you have the name for next week's show in front of you?
I do not.
I got Paul.
It's Paul from FAIR down in Florida. We'll be talking about assignment of benefits and insurance issues in the state of Florida.
I think I've got it. Paul Handerhan, and he is with FAIR, and I forget what FAIR stands for there. Vice President Public Policy for the Florida Association for Insurance Reform. So should be a fascinating show. We met Paul at the RIA conference last week and thought he was very impressive and decided to try and get him on the show, and we were able to do so. So this is Radio Joe saying thanks again to David for joining us, David Johnston, my co-host, the Z-Man, Cliff Zlotnick. John, you got to have faith. Most importantly, our group of loyal listeners. I've got a great, by the way, Cliff, I've got a great prize for whoever got the as long as it wasn't Brian, I've got a good prize for whoever got the trivia question. So give me that information, and we'll be back next.
I'll do that. Actually, we could have two this week.
Oh, better yet.
Kind of a photo finish.
Great stuff. Well, please come back and join us next Friday at noon for the next episode of IAQ Radio.
This has been another IAQ Radio production.